Hi, my name is Xander Salathe, my student ID is 14879, and this is the Coder Academy T3A2 Part B Full Stack App Review. We'll kick off with the app description and overview. So I have a personal history of mainly working in technical support roles. I wanted to create an application that was suitable for myself, but also a wide variety of other businesses. And so I created an application that was lightweight and efficient and really focused on kind of like the core features you need in something to manage incidents or issues. I wanted to include collaboration and communication features, and I wanted this to be free and open source software because some of the larger, more complex platforms like Jira aren't applicable to a lot of small businesses. Looking at the core features of this application, we can create incidents, so easily log or track incidents with detailed information by following through a provided form. We can search and then filter incidents down the track to find out what's happened historically. We can view detailed information for each incident, including steps to reproduce and resolution history. And then also the collaboration piece, so we can empower our teams to work together by discussing, attaching relevant tags and links onto an incident. Looking at the project structure, we'll start with the backend. So we've used a MVC or a model view controller framework for this project. The models capture data layout into a schema. The services handle database operations via Mongoose functions. The controllers then handle the app logic, and the routes provide the API endpoints. Throughout this entire project, we've used Swagger on the backend and JS docs across the front and backend for documentation. And so our project structure is laid out in a way that makes intuitive sense for this MVC framework. Looking at the front end and deployment aspects, the user interacts with the front end via a browser to React hosted on Netlify. The React application makes requests to the backend with Axios, as we've used in this case. The Express.js server is hosted on Render, which provides the app logic and the interaction with MongoDB. The MongoDB instance hosted on MongoDB Atlas. For the front end folder structure, we've gone with a fairly standard React style framework with separate components, contexts, hooks, pages. And we've used Tailwind CSS for styling, so the styles folder is fairly empty. We'll start with a demo before diving into a code explanation. Great, so this demonstration shows what adding a comment looks like for the end user. We'll run through this from the front end to the back end. So starting off at the front end, this React component allows the user to add a new discussion entry for a specific incident. The form layout itself is a text area, which is used for the user input, the placeholder and an onChange event to update the new message state dynamically. The button then triggers the handle add message function to submit that new discussion entry. For the logic for the handle add message, we've included some validation, data preparation, which is creating a discussion data object with message and author fields, which are retrieved from the user JWT, and then make the API call with the add case discussion to send the data to the backend and then clear the input field on a success ready for the next comment. Included with all of these, of course, is error handling with try-catch blocks. Once we've received our Axios request from the front end to the backend API route, we run through various middleware to ensure that the ID format provided is valid, and then to validate the incoming discussion payload. This passes control to the handle add discussion function for processing. The handle add discussion code block in the center of the screen goes through various steps. Firstly, we extract and decode the JWT from the auth header to retrieve the user ID. We then check incident presence to verify the incident itself exists, and then call the update incident by query service function to add the discussion entry to the incident's case discussion field. Again, try-catch blocks for our error handling throughout this process, which sends appropriate HTTP status codes and error messages throughout. We use two DB operation services throughout this process. The first is the find incident by query service, which searches for an incident based on the provided query using the model incident and the find one Mongoose function. The second service that we use updates an incident's case discussion array by adding the new discussion entry. It uses the find one and update with run validators to ensure schema validation is applied. This service is used for updating any field in the incident, so it has more generic logic than something that would be specific for adding a case discussion. As a quick overview, the front end focuses on form submission and user feedback, error handling, ensuring a smoother user experience. The back end separates concerns using middleware, controller logic, and services to ensure code modularity, scalability, and maintainability. Each layer has specific responsibilities between the middleware, controller, and services. Let's look at some problems we faced throughout the project. So firstly, we had an issue where during local testing, everything was functional between the front end and the back end. When we tested on the deployed platforms, we had issues when attempting to read or write any information from the database. As a quick troubleshooting step, I used Bruno to make an API call directly to render to eliminate any potential cause or other issues with the front-end deployment, and the issue persisted. So we started to look at the MongoDB Atlas security configuration. The first thing was just allowing incoming network traffic from every IP address, and the issue persisted actually after that. To get the issue fixed, I had to clear the build cache and redeploy the server on render. And then once that was done, I was able to successfully add the specific render IP addresses on MongoDB Atlas and remove access from all other traffic. There was another small issue with the render configuration. I was able to connect to the database successfully, and I could see the seed data, but when any new data was added, we couldn't see it on the front end. This was due to a missing value in the database URL, environmental variable. During the development process, I'd changed this and then had forgotten to update the render side of things. Quick and easy fix, but an important reminder of keeping variables in sync and why there are third-party tools that exist just for doing that. The second issue that we faced during this process was changing data types between input and submission, and I'll focus in on a specific example. For context, users can add external links to incidents as well as tags. This just allows quick access to relevant information, better tracking down the road. So I've included a view of what that looks like on both the edit or a detail page view on the front end. A problem was that the backend expects an array of strings. The schema showing this for both the tags and related links, with the tags having some extra validation thrown in. Challenge was that the front end captures data as a text area form component, which is just a string. Tags are entered into that text area field with the value bound to the tag's input state. The onChange handler updates the state when the user modifies the input, and then the tags are rendered as badge components for visual feedbacks, which is dynamically mapped from the form.watch. To get this fixed, it took a lot of experimenting, but there were kind of a few pieces to the puzzle here. The first was to create a set of helper functions, which is the array to string function and the string to array function. The first converts an array of tags into a single string separated by commas, which was done through the use of a ternary operator. The second, string to array, converts a string of tags into an array by splitting the string based on commas and new lines, trimming white space, and filtering out empty tags. We then had to use state management as well, of course, local state for the tags, input field initialized from the initial data.tags if available, and then our handle tags change function. So this updates the tag's input state when the user modifies the text area, converts the input string into an array using string to array. So for every character that is entered, we are building the array dynamically. Once finished, updates the form tags value with the transformed array at the very end. These code snippets work together to create a feature for managing tags within the application. The schema ensures proper validation, the form UI captures user input, and the helper functions handle data transformation between user input and then the backend friendly formats. This implementation allowed easier tag management whilst maintaining robust validation. Brings us to the end of the presentation. Thank you so much.